Hello and welcome to our 10th episode in our Pharmacy Calculations Practice Series. Okay, so this question reads, if a physician orders 25% dextrose 500 milliliters and you have 50% dextrose 1000 milliliters, how much 50% dextrose and how much sterile water do you need? Okay, so we need to figure out how much of that dextrose, the 50%, we mix with how much sterile water to get to 500 milliliters at a 25% concentration. Two ways you can solve this. One is by setting up a series of proportions and solving this, using multiple steps of math. The other is by using the allegation method, which may be a little faster, but you need to be familiar and comfortable with that method. I'm going to show you both, and that way you can decide which you'd rather use. Now, if we're going to do proportions, you first need to understand what percentage concentration really means. And in this question, they're expressing percentage as a weight per volume percentage concentration. And that means, or represents, how many grams there are per 100 milliliters of that solution. So a 50% dextrose solution, which is what we have on hand, provides 50 grams of dextrose per 100 milliliters. We're trying to get to a 25% solution, which is going to deliver 25 grams per 100 milliliters. Now, if I'm going to use proportions, the first thing I'm going to do is I'm going to figure out how many grams of dextrose there are in our final order of 500 milliliters. Now, to do this, I always set up proportions with what we're trying to solve for in the numerator on the right-hand side. So how many grams are there in 500 milliliters? When we know at 25% concentration, there are 25 grams per 100 milliliters. Now, when you do this and you put your unknown in the numerator on the right, you need to make sure your units match up on the left. So we've got grams in the numerator, milliliters in the denominator. To solve this, we simply solve that left-handed side. So 25 grams divided by 100 milliliters, and then you cross multiply that 500 milliliters, and we get, let me take out my calculator here, 25 divided by 100 times 500. So this is going to be 125 grams. So we need 125 grams of dextrose. Now, what we have on hand is 50% dextrose. So we need to figure out how many milliliters of that 50% dextrose are going to give us 125 grams. And to figure that out, we set up another proportion with what we're trying to solve for in the numerator on the right. This time it's going to be milliliters. So how many milliliters is going to supply 125 grams? And our known concentration is 50 grams per 100 milliliters. But we need to make sure the units match, so we're going to flip that. So 100 milliliters over 50 grams. And I'm not going to write that out again, but the math here would be 100 milliliters divided by 50 grams, cross-multiplied by that 125 grams. And this X is going to be 250 milliliters. So we've solved half of the question. So we now know how much 50% dextrose we need. It's 250 milliliters. But we also need to supply how many milliliters of sterile water we need. And this part's simple. We need 500 milliliters total. We already know we're using 250 milliliters of the 50% dextrose. That leaves us with 250 milliliters remaining for the rest of that order. So 250 milliliters of 50% dextrose, 250 milliliters of sterile water. Now, to solve this using allegation, let me go ahead and show you how we do that. Anytime you do allegation, you're going to set up what looks like a tic-tac-toe diagram. You put your higher concentration that you have on hand in the upper left. So in this case, it's going to be 50%. and we put your lower concentration on the lower left-hand side. This example, it's 0%. Sterile water has no dextrose in it. And you put your desired concentration in the middle. So we're trying to get to 25%. Now, you're going to take that higher concentration and subtract the desired concentration. And you're going to put that number in the bottom right-hand side. You're going to take your desired concentration and subtract the lower concentration. And you're going to put that number in the upper right-hand side. So that's going to be 25. And what these numbers tell you, this 25 up top is how many parts of the higher concentration there are. So 25 parts of 50% per 25 parts of the 0%. Okay, and if we have 25 parts of one and 25 parts of the other, we have a total of 50 parts. Now we could have simplified this because both are divisible by 25 to one part, but we'll keep it like this just to complete this out. So for our 50% solution, we would solve this by saying we know we need 500 milliliters, and we can multiply that by how many parts of the 50% we're supposed to have divided by the total number of parts. So 500 times 25 over 50 would be 250 milliliters. And for our 0%, which is also known as sterile water in this example, we would do the same. 500 milliliters times by 25 parts of that out of 50 total parts equals 250 milliliters. So both methods take us to the same answer. You can use this allegation anytime you're dealing with a question like this where you have two different strengths, but you need a strength somewhere in the middle. You can always use allegation, but you can always use this upper method as well, which is also applicable for most pharmacy calculations. So I really stress becoming really good at this method, because if you can do this consistently, you can solve almost any question you'll see on the PTCE. If you have any questions about this, or if you have another math question you'd like to see an explanation of, feel free to reach out to us on our Facebook page /PharmacyTechScholar. You can also email us at info@PharmacyTechScholar, or you can just visit us on the web at pharmacytechscholar.com, and you'll see a contact form on our site there. Thanks for watching.